Assalamualaikum warahmatullahi wabarakatuh and very good morning. So today we're going to meet again for another chapter under Computer Architecture Organization, which is under Chapter 5 Memory. Thank you so much for staying with me up until now. So we're going to continue the topic. We have in total of 9 topics. I think we have eight topics at the end. So we almost in the second half of our session. So thank you for subscription of my videos and thank you for the likes. So without further ado, let's start our class for today. So uh, under chapter 5 memory, okay, so basically in the computer memory we have a lot of kind of computer memory. Okay, we have the common one that we have is the one that inside our computer and outside of our computer, which is the inside one is the internal memory and the outside one is the external memory. So the internal memory we can divide it into several types of memory, which is under the register, RAM, ROM, SRAM, DRAM. So a lot of things. Okay, for the external memory, you have with you, like for example, your CD, DVD, your SD card, your flash drive. Okay, your external hard drives. Okay, even previously we have floppies. Okay, so those are what we call external memory. So let's go step by step of covering all the session today. Okay. So basically, inside the memory, we have 8 characteristics that differentiate the type of memory we have inside our computer. So this 8 characteristic is basically the physical characteristics of the memory itself, the capacity, organization, the unit of transfer is used for transferring the data, the access method for you to get the data inside the memory, the physical types, the performance of the memory itself, the location of the memory itself. Okay, so all these 8 characteristics will be representing your memory inside your CPU, inside your PC actually. So please look at the first one, location, where is your memory is located. Okay, inside a small CPU here, we have also a memory, okay, based on our last chapter. Under assembly language, we have what we call the register. So the register is a kind of memory inside the CPU. So register is basically a small space of memory, but it works really fast as the CPU itself. So, and then we have the internal memory. Okay, so internal memory that we have is the main memory of your PC. Usually we call it as random access memory, which is RAM. Okay, and then we have other, like for example, cache memory, or even we have hard drives, we have M.2 drive. Okay, so SSD drive. So all of them are count as internal memory. And then we have external memory, which is types of your flash drive, okay, CD, DVD. In case these days we rarely use CD and DVD anymore. So, and then other than that, we have like for example, previously we have diskette, we have floppy disk, magnetic tape, magnetic disk. Okay, so all of them count as the external memory. So in terms of capacity, usually we have two types when we describe a capacity, which is the data storage itself, which is usually we represent it as word. Okay, so which is the natural unit of organization in the memory, typically the number of bits that you use to represent a number. Okay, so and then we have the addressable unit. So for each data, okay, inside your memory, they don't store it blindly like that. So for each bit, not each actually, for several bits inside your memory, depend on the architecture of the memory itself. Okay, like for example, commonly we have around 8 bits. Okay, so around 8 bits of memory, usually we have around one address for 8 bits. Okay, so in this example, so they are addressed so that when the CPU is requesting a data, they request according to these addresses. So you don't blindly say that I want that data, this data, but you don't know where the location of the data is. So address represent exact location of the data inside your PC, at what place, what location, and from there the information can be taken into your CPU. So next we look at the unit of transfer. So we have two types of unit of transfer. First is bits and the second one is block. So usually if it's fast, the memory is fast, we transfer it according to the bits. But in case the memory is slow, we transfer it according to blocks. So usually bits is in the random access memory, which is the main memory of your of your PC. And then block, usually we transfer it between the main memory. Usually we transfer it blocks between the hard disk and the main memory. Okay, so you take it the data from the hard drives by blocks, put it into the main memory, and from the main memory CPU will take it according to the bits. Okay, and even in case of saving the data, so they will save it according to the block as well. So the number of data elements transferred at a time in blocks in the secondary memory is depending on the instruction on the CPU itself. Okay, so if the CPU want to transfer a certain amount of data inside the uh, hard drives, okay, so usually they will transfer into the RAM first, and RAM will store it inside the drive according to the block. And then we have access method. So how basically the data is being accessed inside your memory. So we have here, for example, of access method. So first one is the random access. Okay, we have a random access which all location has a unique physical address. All location of data inside the memory unit have the unique physical address, and this location can be accessed in any order, and all access times are the same. So usually when the CPU wants something, so they will access it from the memory automatically. Okay, so and then we have sequential access. So sequential access where data does not have a unique address, so the CPU must read all the data in sequence until they found the exact data that it needed. So this one the time need to access data depending on where is the data is inside the memory. So usually this represent, like for example, a tape drives unit. So tape drive unit usually previously, okay, in my generation we have Walkman. So Walkman is where you have cassettes, radio cassettes that have songs inside it, and when you want to look for the specific songs of your uh, from the tape itself inside your Walkman, you have to keep forwarding or rewind the tape, or keep forwarding just to find the location of the song that you want. So this is what happening inside sequential access of a memory unit inside your PC. So this is actually time consuming because you have to move forward and move back, and then suddenly you miss it or something like that. Okay, so this is where you have the sequential access. And then we have what we call direct access. So this direct access is that data, they have unique address, okay, unique address. So access is done using a combination of moving to general memory area followed by sequential access to reach the desired data item. So this is usually inside your disk drive. So your disk drive is big. Okay, recently we even have up to 60 terabyte of hard drives. So you want a specific 8-bit from your hard drive, so it's hard for them to find it exactly. So direct access, usually they will jump it to the area inside your hard drive. So it means that it looks at a cupboard inside your hard drive. They look inside the cupboard of your hard drive instead of they look for the cupboard inside your hard drive instead of looking for the book directly inside your hard drive. Okay, so they look for the cupboard and then they scan the cupboard from the top to bottom, which book is the one that I need, until they found the book. So this cupboard represents sectors inside your hard drive. So based on these sectors, okay, the block of memory will be transferred into your RAM. So basically like that. Okay, so and then last one is what we call the associative access. So accessibility itself is where data items are accessed based on their contents rather than their actual location. Okay, so this means that you want according to the content instead of the actual location. So they search all data items in parallel for a mesh given by the pattern, okay, of the data, and all memory locations search in parallel without regard to the size of the memory as long as they have the same pattern of what they want. Okay, so this one is where we have in cache memory. So cache memory usually we have inside the CPU. So the CPU, the cache memory usually they store our most common data that we use in our PC. So means that data that involve, like for example, games, or usually the most common one is data that involve your web browser. Okay, so they can get it fast. You can open your web browser really fast. So data that does not have inside your cache memory, like for example, rarely used, like for example, your assignment data. Okay, so your reference book. Okay, so this one rarely used. Okay, so rarely used, usually they store deep inside your PC other memory, and it takes time for them to take a look to those memories. So you might need to access from direct access before they get it into the random access memory, and from there associated access will take it from your RAM, okay, and CPU will take it from your cache. So this is basically what happening inside your CPU, inside your PC. So next, okay, in terms of performance, we have three types of how can I say units that we can use to specify the performance of your memory. So the first one is where we have the access time. The second one is the memory cycle time. The third one is the transfer rate. So access time is rate, okay, rate at which data transfer to or from the memory device. Okay, so data transfer from the memory to a location and data transferring from a location to the memory. Okay, this is where we call the access time. So time between presenting the address and getting the valid time. Okay, so this is where you have the access time is. So, and then next we have the memory cycle time. So this one is the access time plus any other time required before a second access can be started. So this means that once you request a memory, until you receive all the memory and finish, this is what we call a memory cycle time before you start the next request. And then third one is transfer rate. How fast data, okay, being transferred from the memory itself to the CPU or something like that. So transfer rate and access time is almost similar, except the access time usually the one that we want is okay. So when you talk about memory, so you need to get requests. You need to request for data first, okay, from the memory. Means that you request before you can take the data. So access time usually involve in requesting. Transfer rate usually involve after you request, you get the data. So this is where you involve the transfer rate. So then next we have the physical characteristics. So memory, they have several physical characteristics. So firstly, we have semiconductors. So this semiconductors is one of the most common one these days. You have SSD, your RAM, your SD card. All of them are created out of semiconductors. And then we have magnetic tapes and discs. Okay, so magnetic discs usually we have in our hard drives, and magnetic tapes is very old now, so we don't have them anymore. So last time, this is your save button inside your Microsoft Office. Okay, so this is what we call a floppy, and this one is diskette. So usually we call it disk or something like that. And then we have here is a roll of tapes. So this one is a roll of tapes where you put it inside this CPU. Okay, so when you want to take any data from this CPU, you have to wait until they read the tape first. So this one is time consuming. So this one is very old. Okay, they launched the astronaut to the moon using this kind of PC. So you don't underappreciate or underestimate this kind of technology. So and then We have this what we call the optical drive. So this one, I think most of you still found it a common thing. Okay, so this one usually we use it to store information that are not intended to be rewritable. So usually we store our DVD movies, we store our a lot of things that you can have. Okay, movies, usually we have movies, audios. Okay, so this one is where we have, okay, in the market these days for us to buy as consumables of electronics arts. Okay, like for example games, okay, and then movies or audios. So these days we rarely use it anymore because we have other options in the internet where you can download it directly inside your PC without using this. And most of the PC these days, they don't have the drivers for this anymore. Okay, mine still have here. Okay, so you might see less of this in the future later on, but I like to use them because I use them as a permanent storage for memorabilia or something like that. Okay, so and then we have the almost the second last one. So this one is a physical types. So physical types of the memory. Okay, we have three types of physical types that you need to consider, which is the first one, volatility. So volatility is when means that it's either volatile or non-volatile. Means that does it need power to retain the data? If it's need power to retain the data, it means it's a volatile memory. If it does not need the power to retain the data, it's a non-volatile memory. Okay, so this is a physical type. So if it's a volatile memory, usually a volatile memory we have in our random access memory where you need to have power so that data remain there. But in case of non-volatile memory, example is our hard drive. So you don't need to have power, constant power to make sure that the data is there. So usually hard drive, the data will be remain inside your PC even though the power is unplugged. Okay, and then next we have erasability. So this means that whether the data can easily be rewritten or removed from the memory or not. Okay, so this one also one of the issue. Like for example, things that we cannot remove easily is like for example CD. Okay, so this is hard for them to be removed. And finally, we have power consumption. How much power does it consume? Okay, so if it's a volatile memory, it will consume a lot of power because you need power to make sure that the data remains inside the memory itself. Okay, and then finally, we have physical arrangement of the bits to form a word. To form words. So how do you arrange the bits? So there is a keyword here, what we call endianness. Okay, endianness is how you arrange a memory according to the address location inside your memory. How you arrange data according to the address location inside your memory. Okay. So next, let's take a look at the type of memory that we have. Okay, firstly, we go into random access memory. So basically, random access memory, we have two types of random access memory. The first one, we have dynamic random access memory. Okay, random access memory, I call it as RAM. Okay, we have dynamic RAM, which is the DRAM, and also we have the static RAM, which is the SRAM. So this example of one bit cell inside your RAM. If it's a dynamic RAM, this kind of cell. If it's static RAM, it's kind of cell. Okay, so in this case, you look at the static RAM. Okay, it looks like it consumes more space than the DRAM. So let's take a look at the characteristic of the DRAM and SRAM. So basically, DRAM, okay, the data stored as charge and capacitor, where static RAM data stored as switches. So this means that if it doesn't need okay, it doesn't need, like for example, it doesn't need constant charges for it to remain the data. So this is what happening when you have charges leak. So if it's stored as charge and capacitor, charge will leak out of the capacitor and it kind of altering the quality of your data. Static RAM, because it's safe as on-off switches, there are no charges to leak. So and then dynamic RAM, you need refreshing even when powered so that the data, the charge is sustained inside the memory. Okay, so it will remain a quality data there. But in static RAM, no refreshing is needed. Dynamic RAM, you have simpler construction. Static RAM, more complex construction. Dynamic RAM, more dense. So means that in a unit area, okay, so there are a lot more memory cell in one area comparing to the static RAM. Okay, so usually our dynamic RAM is less expensive and our static RAM is more expensive if you compare to the capacity of the memory itself. So the DRAM you need refresh circuits, static RAM you don't need a refresh circuit. DRAM you need you have slower access time, static RAM faster access time. DRAM low power, static RAM consume more power because you need to turn the switch on and off. Okay, and the application for DRAM is basically inside your main memory, which is your RAM itself. And the static RAM, usually we have a cache memory inside your CPU. So this is where we use our cache memory. So example of DRAM we have here is cache memory. Okay, no, not cache memory. This is random access memory inside the main memory inside your PC. So the main memory here is connected to a cache. We have a level 2 cache and level 1 cache. So this is example inside the SRAM memory bank. So this one is inside the CPU. But these days, so inside the CPU here, we have the cache memory. Okay, so this one, usually they are very small, but they need fast. So in order for the CPU who move fast, okay, want to access the random access memory, they need to have a mediator memory between the random access memory and the CPU itself, so that the speed of the CPU will not be compensated by the slower speed of the main memory. Okay, so means that the CPU can move at full speed. Okay, we don't need to slow it down to gain access to the random access memory, because the cache memory will keep the transfer of the data as fast as the memory speed itself. Okay, so inside our ROM, okay, read-only memory. Next, we have our read-only memory. So read-only memory is where you have a memory that designed for only to be stored data for one time. Okay, one time only. So you means that originally is for one time only. So you just have to save the data inside the memory itself. So usually the common ROM that we have here, if you see a cheap toys, okay, on the market, okay, that have music on it, usually they use a read-only memory there. So they store the data of the audio inside the read-only memory, so that when you plug in the button of the cheap toys, they can play some of the music from the cheap toys there. So we have read-only memory, and then we have a programmable ROM. So here you can program the memory itself. And then you have erasable programmable ROM. So here you cannot, you can erase the memory but using a certain protocol. And then you have electrically erasable programmable ROM. Okay, here you can use electricity to just remove the data inside your random access read-only memory. And finally, we have a flash memory. Okay, so each type of this has unique characteristic, but they have two things in common. The first one is that they are non-volatile. Okay, it's not lost when electricity is removed. So flash memory is, for example, your SD card. They will not remove the data inside it. Data stored in the chips is either unchangeable or requires a specific operation to change, unlike RAM, which can be easily changed as it reads. So next we have the magnetic disc. Okay, so magnetic disc is basically a disc is a circular platter constructed of non-magnetic material called the substrate, coated with a magnetizable material. So data is recorded onto and later read from the disc using a conducting coil, which is we call the head. Okay, so let's take a look at the image itself. Okay, so because it's created of the aluminium, okay, and currently even some of them created by glass, so they are prone to shock, damage resistant, okay, but because of there are a lot of mechanical functions inside the memory, so there are a lot of higher risk in preserving this kind of data. So basically, we have, this is example of hard drive. So hard drive, okay, this is the head of the hard drive. So you can see this is the head. So imagine that this is the head scanning the drive itself. So the drive is like a line, a lot of line from the outer layer into the inside layer. So in the line, they have like for example, this magnet, the head contain magnets. So these magnets will magnify, not magnify, it's like magnetize the this towards a certain magnetic direction. Okay, so different some magnetic direction, okay, it will be represented as 0. So another one, it will be represented as 1. So in case this one, left might be 0, right might be 1. So this magnetic head, they will change the direction of this magnetization inside your disk. So this is where the data being recorded. So basically, the data is recorded according to sectors. So you have sectors here, and according to these sectors, you have certain blocks. Okay, so it's like a big city with a lot of roads, with a lot of blocks, where you have all those people inside the blocks. It's like inside the apartment. Okay, so you have a lot of tracks, and then for each area, okay, sectors and lines, you have addresses. So these addresses is what being used for the CPU to refer to the data inside the drive. So, okay, in terms of looking at the performance parameter of these hard drives, okay, you need to look at the seek time, the rotational delay, access time, transfer time, so that you can understand whether the memory is good or bad. Okay, so seek time is the time it takes to position the head at the right track. Rotational delay, time it takes for the beginning of the sector to reach the head. And then the access time, the sum of the seek time and the rotational delay. Transfer time, which is the time to read the block from the sector, from the disk to transfer it to the main memory. So this is one of the things, some of the things, 4 things actually, for you to determine the performance of the hard drives. Next, we have the optical disc. Okay, so in optical disc, which is data stored in an optical medium. Example is CD, DVD. Okay, so reading the data is basically we use a laser beam. It's not a practical for use in computer processing, but it's ideal solution for storing large quantities of data very inexpensively, and more importantly, transporting the data between computer devices. So we have, like for example, CD-ROM, where you can only have a read-only memory. You have CDR, which is recordable, CDRW, rewritable. DVD means digital versatile disc, and we even have what we have Blu-ray these days. So the difference between all these discs is that the type of laser being used to read the data inside the disc itself. So currently, we have the Blu-ray disc where you have, for example, in PlayStation, you have a Blu-ray disc to store games. So this Blu-ray disc, they have a much smaller laser beam head comparing to the CD drive. So smaller head of your reader means that you can store more data inside the same size disc comparing to the larger head. Okay, so this is what happening uh, inside your CD drives. And then we have the magnetic tape. So this magnetic tape is where you have a big, like a tape, okay, a big roll of tapes that you can store data inside it. Okay, last time we use it is for us to store movies and also audio, okay, audio for your Walkman. Actually, is like your portable radio. It's before we have the iPod here. Okay, so this is one way of the PC used to read the tapes. Okay, the tapes is being inserted inside this PC so that it can read the data inside the PC, inside the tape itself. So this one is very slow, and then this is very cheap, and taking the data is time consuming. Okay, I think that's all for today. Okay, I will continue in another video later on. So thank you very much for your attention for today. So I'll see you guys next week. So that's all from me, Dr. Sharif Fauzi Kamaruzaman. Thank you for your subscription and for your likes. I'll see you guys next time. Bye bye.